Hello, this is a new version of Graphics Framebuffer. And I'm going to show you how to install it, and I'm going to show you how to make it work. It's actually not too difficult if you just do everything you're supposed to. And I'm going to show you what you're supposed to do. First of all, this package is available on CPAN or it's available on GitHub. I recommend the GitHub version simply because it's, in my opinion, it's easier to install and it doesn't cause as many problems as the CPAN version. CPAN tends to do things in a dictatorial way sometimes and forces an install, especially if a module like the module imager allows you to install it without any of the development prerequisites, which causes a problem. So I recommend installing the CPAN one. And the CPAN one, if you, let me get you the address. The CPAN one is this address right here. It's github/rich_csst/graphics framebuffer. And if you want to clone it into your own repository, use this. I'm going to copy that. I'm going to copy that link because I'm going to show you something here in a sec. You go in, once you grab that link, you go into your terminal over here. Now I'm in X Windows right now. We're going to be out of it pretty soon. But I'm going to do it so I can copy and paste because I'm running on VirtualBox, which is a emulator. But I'm going to just type git clone and then paste in that address. And then when you're all done, I've already got it in there, so I don't need to clone it. But once you've got it in there, you'll have your graphics framebuffer directory. And inside that, you'll have your list of files. Now, if we go back to the GitHub, oh, wrong. I got like 4 monitors here, so I got to make sure I'm showing you the right one. You'll see they have the same basic files that are listed inside the Ubuntu. There's a few extra ones on my screen simply because I'm the developer and I got some handy dandy utilities that help me with that. Save time because I already know certain things that will work and don't work and so forth. But those are not included on the GitHub repository and they're not really a big deal. So don't be concerned with them. Well, anyway, here you have your list of files. There's README that you can look at. It shows you everything in detail, operational theory, tells you all the steps to install and where to go. We're going to cover that, so you don't need to really go over it. It shows you how to install it in VirtualBox with EFI, if you have an EFI Linux. It's more involved steps if you don't use EFI in Linux. So I recommend using EFI. This shows you where to add extra configuration to the VBox file for that specific emulator. You can set up the frame buffer to be 4K or whatever resolution you want it to be. Mine is set up to be 4K. And then it shows you how to, once you've done all the installed all the prerequisites, all the prerequisites and everything, it will then show you how to do the typical Perl install. And as you notice right here, build.pl is not supported because inline C doesn't support it. So that's why we do it the old-fashioned way. Although I think build.pl has actually been rendered into the junk pile. I don't think anybody uses it anymore. I think it's back to the original. There's also further test scripts and so forth, different directories. Well, first of all, I'm going to show you how to install it. So let's go to installing. And I'm going to switch to my terminal now. And so you can see, I got to put the mouse in the right place. You can see what I'm going to do, but I have to actually switch to the Linux terminal and get out of Windows. I'm going to hold Control, Alt, and hit function key 5, F5, and then we're going to a terminal. I'll log in. Mine's Rich. I'll type in my password. It's going to do its thing. And then I'm going to go where my repository is. And I have it in a place called Source GitHub. Then I'm going to Graphics Framebuffer. And then here we are, back to where we were before. So I'm going to go to installing. Look at all the different files in there. Now, first of all, you're going to want to know what your distribution is based upon. I happen to be running Ubuntu, which is based upon Debian Linux. There's two main ones we're worried about here. Is it a Debian-based system or is it a Red Hat-based system? And if you're not sure which one yours is, just run a file called detect. Just run it like I just did right there. And it will show you all the different systems it knows about. And then if you go down to where it says operating system, down on the bottom, it says Linux Debian. So yours, this is a Debian-based system. Yours might say Linux Red Hat or something similar. So don't worry about it. You just need to know which one is which. You know, is it a Debian system or is it a Red Hat system? We found out it's a Debian system. Let's move on. Let's go to install prerequisites. Run that, and we're going to run the Debian version. And then it's going to install all of the necessary operating system libraries and files to be ready for this module. I have them all already, so it's just going to say I've already got all the right versions installed. Then it's going to hit a point where it's going to ask me a question. Do you want to load the system or packaged Perl versions? Unless you've got some kind of a fancy system set up, answer yes to this because you're running the packaged Perl. Okay, so let's do that. Answer yes. And I already have these installed, but it's going to go and try to download all the different ones that it needs. And so once you have this step done, you're almost there. Okay, so now let's get out of the installing. We'll go back here, and now we're going to actually try to install Graphics Framebuffer. All the prerequisites are ready. We try to install. Now, before I actually run this, there's this. Everybody that has installed the Perl module knows about makefile.pl. Now, what it's going to do, it's going to check for a lot of different things on your system. It's going to merge the C code and the Perl code together and then be ready to compile the C code when we hit make. But it also, I've added this feature, it also checks to see if your user account is a member of the video group, because it's very important that it needs to be a member of the video group or you won't see anything on your screen from this module. I know it might even give you permissions errors, okay? Because the your frame buffer requires membership with the video group, okay? I'm going to temporarily pretend my account is not a member of the video group, but I'm going to force the code to think that that's the case. And I think I scrolled too far. Yeah, here we go. This is where I check to see if you're a member of the video group. So I'm going to pretend that I'm not. And this is what's going to happen when I run this if I'm not a member of the video group. It's going to go, oh, wait, is Rich a member of the video? And it's going to say no. And it's going to spew this on the screen, but it's also going to give you an example of what command to type to make yourself a member of the video group. You can just copy and paste this if you want, but sudo usermod -a and a capital G, the video group, which is video, and then your account name. But in my case, it'll say Rich. Whatever yours is, it will say that. It gives you the example from this utility. So you run that line, and when it's done, you need to log out completely. Then log back into the terminal then it will start working. Okay? So I'm going to go back and edit that patch out again because I'm already a member of the video group. Okay. All right. Now we're going to run that makefile thing again. But this time it's going to see that I'm a member of the video group and continue on. It's going to do a whole bunch of different things. Now it's going to, if you go up under the logo up there, it says it found a frame buffer, which is frame buffer 0. And it says, yes, I'm a member of the video group. And then it loaded in the C code. It loaded in metadata, which is important for the resulting module. And what it does is it merges a whole bunch of different things together, sets up version numbers and so forth. And then when it's all done, it copies the new copy of framebuffer.pm over to the library directory. It's all technical. You don't need to really care about that. Just know that it's ready to go, all right? And it also gives you a list of files you can run to test things out. And then also at the bottom, it gives you the commands to type to finish installing this. But it also says you need to make sure, it says, please pay attention. You need to make sure that you have all the prerequisites installed. Well, since we went to the installing directory and ran that installer, we have the prerequisites installed. But this is here just in case you didn't do that. All right, so pay attention to any negative messages that are in that little section there. Well, we're good to go so far. So next we type make, because that says that's your first step. You type make. First you do make, and then you do make test, and then you do sudo make install. Okay, so let's do that. Make. It's going to compile the C part of the module. It's happy now. It's ready to go. Now we're going to test what we've done. So we'll make test. Now it's just going to show the splash screen twice. It's going to show it in Perl only mode where any of the C code is not being used. And then it will show it in the C code mode where it's a lot faster. The splash screen is a little different if you're in each different mode because the C code uses alpha drawing a lot because that's transparency and stuff. To do it in Perl is a lot slower, so it doesn't do it. So pay attention. This is what it does. It's Perl mode. Notice the boxes are solid, and now you notice they're see-through. Since that worked, that means the module's working. So it's happy. Your testing was successful. You passed. Now let's actually make it permanent part of your Perl installation. So let's sudo make install. And sometimes sudo will ask you your password. Since I've used sudo already, it hasn't asked my password, but it might ask your password. Go ahead and type your password in if it asks that. Now, if you get a directory, you got this big mess. Well, to get the big mess out of there, you just type make very clean. It deletes all the excess garbage that it put in there, and now you're back to normal, like a normal screen. Okay, now everything should work from here. Now, if you want to do some testing and run some of the examples, we can do that. We can go into examples. And the file to go to is a file called primitives. What primitives is going to do is it's going to run as many of the features of Graphics Framebuffer as possible. If you look at the source code to primitives, it's written in a way to where it's really easy for you to read. It's not optimized on purpose. It's very easy to read, very easy to get an idea of what it's doing. It helps you when you read the documentation to refer to that. So I highly recommend running primitives and then also looking at its source code if you want to see what it's doing. Dump is for debugging. That's what you run dump and then it creates a file called dump.log. You would attach that to an email to me. There are instructions in the library here how to send me an email. So that's how you get some help from me. But make sure you do everything possible before asking me because you might be waiting a while. I mean, I got other things to do, but I will help you when I see your email, okay? And I have the time. There's also screensaver. It's just a really stupid file that prints the time to the screen in random locations. That's about all it does. Shapes will draw some different graphical shapes. I think it's a dumb program, but I left it in there. Slideshow does exactly what it is. You can, if you run slideshow as it is without any options, it will run what's up in the images folder. It will show you all the pictures that are in the images folder. If you give it a folder path, it will show all the images in that folder and any subsequent recursive directories with images in it as well. So that's a really handy slideshow program. It will show the images in their native format or whatever the largest resolution the screen is. If you want small images to be increased in size, you have to type in the -- full option to the command line. Then there's template.pl. That's a template file you can use to write your own scripts. If you copy that file to a new file, then use the new file as your base, then you've already got the skeleton for running the Framebuffer, which is very handy. There's a file called textmode.pl. That's if for some reason your script crashed or you Control-C'd out of it and you didn't put in a trap to reset the screen. Well, normally this isn't an issue anymore, but if there's some weirdness, you blindly run that file. You blindly run text mode, and it will reset your screen and get you back to normal, put you back in text mode, because when the module runs, it's in what's called graphics mode. Okay, so if you do that, it'll just reset your screen. Vector is a kind of... Here, I'll show you the listing of this. Let me less Vector USA. This is a file that just simply draws, using simple commands, draws to the screen. Okay? Just simple commands. And if I do vector, then that file I just showed you, it drew it absolutely fast. Let's try it again. Oh, wow. I'd figure that out. That's another thing. Worry about later. What it draws is the United States flag. It's not a big deal. Let's see. View pick just does what it says. You type view pick, and then the file name you want to view, and it just shows you a picture. I think for about 10 seconds or so, and then exits. It doesn't resize the image at all. It shows it in its raw format. If you want to resize it to full screen, you just do it like you did on the slideshow program. You use the option -- full, and it will show you. So let's go over primitives. Primitives. I'm going to go into the source code here first. Show you something in primitives. Let me go down. Okay, primitives has a list of things that it will run, and it's just basically a simple hash that it uses to run all these different types of graphics primitives. And this is a list of, in order, what it's going to run. I think I have one of them or two of them commented out because multiply and divide modes just look ugly. There's also a way you can just run one function, and that's with the function option, which I'll show you later on. But right now, when you just run primitives, you just run it like this. Now, since I'm running this in VirtualBox, and VirtualBox's latest version has got some really weird buffering happen. I found if I just use the switch flush, it will flush the buffer to the frame buffer, and you won't have as much of an issue, because if I don't have flush turned on, you'll see like weird weird jerkiness to things. It's like it's filling a buffer up and then dumping it, filling a buffer up and then dumping it. which is probably what it's doing, but it didn't do that before. This is the latest version of VirtualBox, and now it's suddenly doing that. Well, I'm doing flush, and that minimizes that like crazy. So that's why I'm using it right now, because that's what I'm running as a VirtualBox machine. So here we go. Right now it's loading images, and that's what you see up at the top. The longest one to load is the animated GIF. There is one animated GIF in this example. But once it's loaded, it doesn't have to load it later on. It keeps everything in memory, and it's loading all the static files. But first it's going to go through all the actual graphics primitives. Show you. First it shows you the color horizontally and vertically. Shows you a test pattern, and then it's plotting, drawing lines, drawing angled lines, polygons, anti-alias lines. This is one of the routines that I've increased in speed. Used to be Perl only, now it's C accelerated. All these are nice and accelerated. Things are running a lot faster. Although it was pretty fast with just Perl only, don't get me wrong. This module started as a Perl only project. I only added C later on just to speed things up. And it has sped things up, but still there's a lot of things in here that are still Perl that you don't need to have C for. I've tried it. I've tried some things in C and the speed wasn't any different. So there are some ways you can get Perl to run pretty darn fast if you're tricky. What it's doing right now, the filled polygons and the hatch filling are done in that with the Imager library. Something in the future I hope to eventually eliminate the need for and use my own graphics library, but Imager unfortunately is necessary right now. I like Imager, don't get me wrong, I like it. It's just not as fast as I need it to be. And it doesn't do 16-bit color. I have to convert it from 24-bit color to 16-bit color to work on 16-bit graphic screens. I mean, it works, don't get me wrong, it works, but there's an extra layer involved, which can slow things down a little bit. But as you can see, there's different gradient shapes and so forth you can have available, as long as normal filled, hatch filled, things like that. But these are all the different things you can do with this library. The reason why this seems a lot slower is because it's resizing each image before it shows it. If you already have the image the size you want it to be, then it's going to be a lot faster. And you'll see what I mean in a minute here. As you notice, it's filling in different shapes. Now it's doing ellipses, it was doing circles and squares, and now it's doing pies and so forth. And polygons. That was a flood fill. It used to be slow and Perl only. Now it's C and it's almost instantaneous. So that's a new thing on this latest version. Two-type font printing. Still haven't got this working perfectly yet. It works only within 90 degrees, but I'll eventually get it for full 360. This is color replace, full screen, and then it's going to reset and go color replace in a clipped area. Yeah, here, if you already have your graphics already pre-sized, it's fast. See, now it's moving all over the place. That's blip move. And then rotate. Or inverting, horizontal and vertical. Page flipping. Then monochrome bleeding. Uses a specialized formula to convert to monochrome that just about every graphics package in the world uses. Basic color weighting. And then combining. Now it's showing you the different modes you can run. That's alpha. That would have been a lot slower in Perl, the alpha drawing. But as you can see with C accelerated help, first you see in Daffy Duck and Bugs Bunny in raw resolution, and then it's going to show you it in gigantic resolution. Ever since VirtualBox changed their frame buffer, the way they handle the frame buffer, it's gotten to be a lot slower. Normally, with those two, with that animation, I could be thousands of frames per second to give you an idea how fast it was. Now with all this flush stuff, I have to. It slows it down. So if you're running on raw hardware, I assure you the animations are a lot faster, even for a Raspberry Pi. Let's see. We've ran that. You got to see how it runs. There are options and ways to change how you run each of these. And if I remember correctly, if you Perl dock those, like Perl dock primitives, like we just ran, it will show you all the switches and so forth you can use to change how it operates. Okay. There are multiprocessing examples, both in Perl threads and with MCE, which is Mario Roy's method. His method, I think, is a fancy way of using forks, which means it runs on Perls that aren't even compiled for threading, so which is really handy. Threading involves different ways of doing things versus MCE, but either one runs just fine. If you want to get the MCE demos, you would just do get MCE demos, and it goes to GitHub and downloads them. You can see. And now you have these examples. So I'll show you some threaded examples. Many boxes. I don't have the necessary files installed. You need MCE Hobo and MCE. I'm not going to bother with those right now because that's not really part of the module. Sorry about introducing this. There we go. But if you want to do like threaded primitives, I'll Control C out of it. We don't have to watch the whole thing again. But threaded primitives. See, it's drawing a whole bunch of things at once. I think it's using 6 threads. It's all over the place. Because it runs on VirtualBox, it looks slow, but when you run it on real hardware, it's just going all over the place. It's super fast. It's running on all the cores and so forth. It's automatically detecting how many cores to run on and so forth. But let me get out of it. Is it done yet? Yeah, it's up there. Let me reset the screen. There we go. There. And same thing for slideshow. If I want to do a threaded slideshow, it goes in and down, and grabs all the images in different threads. And it'll even play animations as well. And you can point it to any directory you want, just like the other. Let me Control C out of it. Now it takes a little longer to get out of the threads. There we go. And there's also a template in there if you want to start your own threaded template. Remember, copy this file to a new file and work on the new file. That way you don't mess this one up. And it explains in there exactly where to start your own code, what code to use in here, and so forth and so on. It even has a SIG alert handler. If somebody hits Control C or whatever, it shuts down all the threads in a very nice and friendly manner. So it doesn't crash or sag fault or anything like that. Well, let's see. We're back to examples. Yes. Let's get back. Whoops. Duh. I do believe that is it. Let's go over to GitHub. There are a lot of very handy files. Whoops. Wrong button. Sorry. A lot of very handy files to read in here. There's a frequently asked questions. And it shows you different answers to different things. Some are obvious. It's like, does it work with Microsoft Windows? No, it doesn't. Does it work with FreeBSD or Darwin? No, it doesn't. It only works in Linux. It says, will it ever be hardware accelerated with DRM video? Not likely. I cannot get it to work. Will you help me? Yes, I will help you. But if I find that it's a lost cause, then I'll say it's a lost cause. But most of the time, it's not a lost cause. There are known issues with the graphics frame buffer, and I explain here what they are. It says here, avoid 16-bit mode if all possible. Raspberry Pis originally are configured for 16-bit mode. I suggest going into the configuration file or the Raspberry Pi configuration and changing it to 32-bit mode. Believe it or not, 30-bit mode is faster. Why? Because Graphics Frame Buffer uses another module called Imager. Imager only works in 32-bit and 24-bit color mode. It does not work in 16-bit color mode. So I have to do everything in 24-bit color mode and then convert it down to 16-bit mode. So that's an extra layer, which means extra time, cost, and CPU time. And since Graphics Frame Buffer, everything is done with the CPU. There is no GPU whatsoever. GPU operations weren't even thought of at the time the frame buffer was first created. It is just basically a section of memory that the screen is shown from. That's it. That's old school. That's what a frame buffer is. It also says loading very large images can crash your system if you don't have enough RAM. That is very true. Make sure your images are pre-sized on your file system so you don't have to resize them. Occasionally, there's an operation for mode drawing that uses mask or unmask. Sometimes in 16-bit mode, you can have problems with unmask. Just use mask mode in a reverse way. Mask and unmask are basically polar opposites of each other. It just matters which order you have the images in and how to place them. Just reverse the order and you've got unmask. That sometimes, not all the time, but sometimes can have problems in 16-bit mode because of the conversions and stuff. Console status methods, they're not really reliable. They're there if you want to use them. Maybe your system responds to them properly. Sometimes systems don't. As we've seen here in VirtualBox, now the frame buffer driver is being slowed down for some stupid reason. That wasn't. It used to be really nice before. The NVIDIA Novu drivers suck royally. Don't know why, but who knows? Maybe they're better now. This has been a few years since I've tested those. Most other drivers like Intel and stuff, they're super fast because they set up the frame buffer properly. I have a mouse methods inside the module. I don't recommend using them. They really suck. This is the version of VirtualBox I was talking about. As of that version, you got weirdness in the frame buffer. Anything before that should be no problem, nice and fast. Frame buffer operations. I don't know what they did in 7.26, but whatever they did, it was stupid. Let's see. That was known issues. What do we got next here? We have nothing in the install, although I think install itself Shows you the same steps that I was showing you, how to install things. I even have instructions in here how to do it with Perl Brew. I don't recommend Perl Brew. You don't need that anymore. Everybody uses either AMD or an Intel processor or ARM, and most of your distribution Perls are installed, optimized for those three processors. So you don't really need Perl Brew anymore unless you want to get into some cutting edge Perl version. I don't recommend it. Let's see. Source. You want to know what's in there? Really simple. The source code. Source code for the C. This is the C source code. This is what makes things a lot faster. I would not recommend touching that, but that's why it's there. This is the actual source code of the actual module. There's placeholders in here to put things. And so this isn't what CPAN looks like. When I prepare the system for CPAN, it will create Framebuffer PM to be something gigantic, which is what CPAN uses for documentation. But on GitHub, it's just an empty file. See, it's just empty. That file is created from the source file. So don't get it messed up. These are the tests. I think there's only 2 tests in here. No, 1 test. And it shows you there are some special environment variables you can pass to run the tests. By default, the test runs both Perl version and an accelerated version. If you just want to see the Perl version, you can tell it no acceleration. If you don't like the splash screen, say no splash, but it's kind of stupid because that's all it runs is a splash screen. The delay, you can change the delay. You could ignore the check for X Windows or Wayland, which is very dangerous, but if you want to live on the edge, go ahead and use that. And GFB small, off the top of my head, I can't even remember what that is. I think small is, it runs everything inside of a tiny area in the middle of the screen, just in case you're having some segfault problems. Most people don't have those anymore, but if you run it in the test in small, it shows you that the actual module works. Because if you run it normal mode and it crashes, then you know there's some kind of weirdness going on. You don't need to worry about that. Author just pretty much explains about me, who I am. Really small blurb, not a big deal. Changes, if you want to look at the change log. Somebody asked if I could put the most recent one at the top and the least recent on the bottom. I did that because I'm not a jerk. I'd like to help people out. Excuse me. Licensing is under the Perl Artistic license. Let me mute my mic for just a sec. Okay. And this explains the license for anybody who's interested. And it's just an ASCII file, so that's why it looks kind of weird on GitHub. Most of these graphics here in this directory are what you see on the README files. GFB, I think, is what that is. GFB Pong. And of course, Win and Super Me were for some of the other files, but that's about it. You know, everything should be working. You should be able to code based upon the template file that is listed in examples. If you use the template file, you can't go wrong. See, it says your code in here. You put everything inside there and leave this to shut down, leave this to initialize. Use FB, capital FB is your Framebuffer object, and you can do all of your commands and so forth inside there, and it will run perfectly. So really handy. The only thing you probably need to change is down here. For when your code is done, you can put in your documentation, but there's a template for that there too. so that you're just ready to go. I hope this has helped you and made things a lot easier for you in installing this module, and to see also how much faster it's become versus the older versions.